3, 2, 1, 6.5. So this pretty much summarizes what you should know. And if you're doing the exams, this is the type of questions you'll be doing, which is why for the year 11s, you don't have this exercise equivalent, because in year 11 it's about theory. In year 12 is about application. So you'll find that there is no link to it. So you have two options today for year 11s. You can do this exercise to get a practice of application and revising your skills, or catching up on work. That could also be today's lesson as well. Okay, so it's up to you. You've got two things to do. Either you do the applications from the year 12s, or you can go back and make sure that you've got all the exercises done before I check in week 7. Okay, video great. What are things that you must know from chapter 6 so far? The mean, knowing when and what. So the mean is calculated using, fill it in, every data. This is a key component. When you're looking for the mean, what's the formula for the mean again? If you want to find the average or mean, let's go with Billy, because this will help you for the quiz. How do you find the mean again? And how do you find the average?
By calculating even numbers and dividing it by how many.
Very good. So this is going to help you later, because you're going to be having these kind of skills. So yes, you sum, which is add all the numbers together. Add all numbers together and divide it by the number of numbers. Now, one of the key things is when you calculate the mean, it has to add every number. So that means if you have an outlier, you have someone that has an extreme data, it affects your mean because it's part of your calculation. So every data gets added. This means it also includes the, and fill this in, outlier. This is one of the reasons why an outlier is bad for the mean. And the best example I gave to you guys was annual salary. So annual salary, if they quote it in the news, they say it's 100K, 6 figures. But we know that on average, that's not true. It's about 70 to 80. So why is that the case? It's because there's some people who are earning way beyond what the average is. They're earning like 500K to 800K. That's why it skews the data. So that's why mean is bad when you're using every data, and the data includes outliers, so extremes. That's why you don't use mean when there's extremes. But median, on the other hand, is calculated by ordering the data from smallest to largest. And so it doesn't include every individual, even if you have someone who's in the very end. The middle is just the middle. It doesn't matter if you have someone who's got $1 million per year, the middle is still the middle. That's why the outliers don't affect the median. So here it includes every individual data value. Okay, but it doesn't include all the positions. That's why in the calculations, it doesn't get affected by the outlier. So that's one of the biggest key reasons for year 12s who are wanting to do the exam. That's what you got to take out, because that's the explanation. So those who did the quiz, you notice the end page. I asked you, when do you use a histogram? And when do you know not to use it, or which graphs are appropriate? That's the kind of year level that you'll be doing at the 12 exams. Okay. Next bit. Mode, we all know it is the most common, frequent, doesn't matter which one you can write. So frequent, common, popular, common occurring data. So that's the easiest one to see in a graph, the one that has the biggest column or bar. Range, this is just for some students, and I noticed even when I teach other classes as well, when we say range, we think in terms of English language. We think about, oh yeah, it's from here to here. But mathematics, when we say range, we actually mean a value. And that value is calculated by taking the largest minus the smallest. Okay? And I know that symbol there, a lot of students think that means between. It's not between. It means subtract. So if I told you the smallest number was, 1, and the highest number was 10, then the range is not from 1 to 10. The range is 10 minus 1 gives you 9. Okay, so 9 is the interval. That tells us there are 9 units between the smallest and the largest. Okay, so there's not a range the way we think of it in English. In mathematics, we mean the actual unit, how far they are. So it's calculated by the difference between the maximum and the minimum data. Now, because it's the maximum or minimum, sometimes the outlier, if they're so extreme, they are also the maximum as well. So they also affect the range. So if I had a class that had, say, 2, 4, 4, 3. Oh, sorry, I should write a 3 over here. 3 as their percentages, and then suddenly I got a student who's got 99. Maximum is 99, minimum is 2, but that person skews the range. So that's why outliers affect the range, just like it affects the mean, because you're counting it as part of your calculation. Okay? So here, this doesn't include all values, but it does include the outlier. So it doesn't provide enough information for analysis. You don't know anything in between, but it does tell you one thing, that if it's really wide, there could be an outlier involved in there. Okay? Finally, interquartile range. Most of you understood this in the quiz. It is the difference between Q3 minus Q1. If some of you struggle with that, it's because you found it tricky to find Q3 and Q1. So it means that one of the exercises, like 5.7 for the year 12s, or 14.3, that's probably where you got to practice again. Q3, Q1, it's how to find the middle of the bottom half and the upper half when it's odd numbers or even numbers. Okay? All right. So therefore, it overcomes the problem of outliers. Why does it overcome the outliers? Because they're medians. They're positions. They don't calculate all values. So not unless you include all values, so it doesn't include. So notice here, it doesn't include all values. So what's the pattern? If I link it for you to see, mean and range get affected by the outlier. Why? Because they include the outliers in their calculation. Median and IQR don't. Why don't they? Because you're finding the position. You don't actually use the outlier. That's the explanation towards the end of year for year 12s and 11s if you want to do 12 exams. That's the explanation they're looking for end of year. Okay? Standard deviation, you're only meant to know, like you get a sense of it, but in your exercises for your formative, you had to either do a hand calculation or I would suggest to do Excel. And I'll show it to you how to do it on Excel later. Okay? So, standard deviation is calculated using every data, just the same, because remember the formula was to find the mean of your errors. So every data, hence the outliers, will affect the data. So standard deviation is very similar to the mean. It requires that you find the sum. Now you don't need to know the formula, I'm just showing you. Because you add the mean to it, that's why the outliers affect standard deviation. So that's for year 12s. End of year, standard deviation does affect outliers. So here we go. I color-coded it for you. Mean, range, and standard deviation all affect the outliers. Okay, so if you have outliers, that's not usually the best way to calculate. Median, IQR is better. Okay. All right. On the bottom. So when to use? Essentially, you use mean when there's no outliers. I'm going to highlight them. No outliers for mean. Range, no extreme values. Use the range. And standard deviation, same thing. No outliers. That's one of the key components. I'm color coding it for you to see. All right, so mean, range, and standard deviation all get affected by extreme values. If you don't have extreme values, then you can use them. Then it has more meaningful sense to it. Everything else, use median IQR. So if I put that in the next quiz, that's the kind of explanation I expect you to be able to draw out for me. Here we go. If the data is, skewed, or they're outliers, take it is also fine to use median when it is symmetrical. And if data is skewed and has outliers. Okay, so hopefully I've drilled in. If you were to take out in the last 9 minutes of what I just said, the only thing you have to take out is when do you use it, when don't you use it? It's either you have outliers or you don't. Blue means outliers, don't use. Yellow means has outliers, okay to use. Okay, so write that as part of your notes so that you've got some understanding. Okay. Pink was, I should have done yellow. Oops. That should be yellow. median, and interquartile range. Sorry? Oh, mode is the most frequent number, so it wouldn't. You can do mode for any. Yeah. So blue means when you have outliers, don't use those. Yeah, so or use blue when there's no outliers. Use yellow when there are outliers. Yeah. I'll write it again just so that you know. So yellow, outliers, use. In blue, use when no outliers. That's pretty much in the last 9 minutes. That's what I was trying to say. Anything that I highlight in blue, mean, range, and standard deviation, use when there are no outliers. Yellow, anything I colored in yellow, so median and interquartile range, use when there's outliers. It's a much better calculation. If you did the mean, it inflates your data. There's no point interpreting it. Okay, so in the exams, that's what they're going to do. They're going to give you all of this, and then you have to determine which one is not suitable and why. That's the year 12 level. So year 11s, you don't have an equivalent exercise that practices that. Okay. All right, there we go. That was the summary of what you need to know from 6.5. 6.5 just needs you to know blues, mean, range, standard deviation. Don't use if there's outliers. Median, interquartile range, use when there are outliers. Okay, so outliers are better with medians, and outliers are not good with means and ranges. Okay. Then we'll do one example, and I'll show you on a Excel. I prefer using Excel. I mean, you can use your calculator. It's a bit slower, but Excel to me is the fastest way to answer these questions in 6.5. So that's mainly for year 12s. For year 11s, it's up to you. You can use Excel or calculator. It's not part of the SAC, so in the SAC I won't be assessing the interpretation component, but I do expect that you guys can calculate that. So you will have to learn how to use it on a scientific calculator. All right. Here we go. Let's do one example together, team. Flip over the page. Here's an example. So at year 12, they'll give you a scenario. So here's the scenario. Sample scores achieved by 2 students. So you got students named John and Penny, 2 students. They have done 8 mathematic tests throughout the year. So kind of like you guys, you might do 8 tests throughout the year, or 8 quizzes. So they did 8 of them. Test 1, test 2, test 3, test 4, 5, 6, 7, 8. Now, if you look at the numbers, you can see that each person's getting slightly different. So John loses to Penny in the first one, beats Penny in the second, beats Penny in the third, loses to Penny on the fourth. So overall, if I had to ask you, just looking at this, who did better overall? So it's hard to tell without analysis. For the year 12s, you have to interpret, well, what type of analysis are you going to do? So here's the first question. Now that you got the data of John and Penny, which one's the most appropriate measure of center and spread? So let's think about center. You have mean, median, mode. Spread, you've got range, IQR, and standard deviation. Based on what I have shown to you, which one for center and which one for spread? Now this one, I would say most students in year 12 would not know how to answer. So, who wants to have a go? Which one is it? Because there is one key information here that then tells you which one you should do. And that's where I'm trying to highlight 6.5, the essence of 6.5. Which one do you use? So you can do all mean, median, mode, but there is an appropriate one. Which one is best for John and Penny score at the moment? Or we can do a poll, actually. Maybe that's better. So you guys can look at each other and think, which one should I choose? You got a 50-50 or 30-30, really. Here we go. Hands up if you think the mean is an appropriate measure for the center. Hands up. Oh. Hands up if you think it's the median that is an appropriate measure for the center. Hands up if you... Okay, we got one. Hands up if you think it's the mode. Median or mode? Mode. We got one for mode. And hands up if you're unsure. All right, good. So most of us is unsure. That's okay. That's good. The answer is mean. Now, why? Why is the mean an appropriate measure? Now, we can't tell if there's an extreme. Okay, so remember I said if there's outliers or extremes, don't use the mean. Right now, we can't tell. So, why we're using the mean is because you're calculating for every data point. As soon as you include every single data point, it's the mean. Okay, so every data point, it's the mean. If you're not including all data points, then you can use median and such, or mode. So in our case, the mean is going to be the most. So here I wrote a little blurb for you to remember. Since to compare, we need to calculate all, and I bolded it for you. All the data values, the most appropriate, can you fill it in for A, is mean for center. So if you want to know where is the population sit, you're going to do mean because you're calculating all the data values. Had you not been calculating all data values, then you don't have to do the mean. Okay? So you're calculating for test 1, 2, 3, 4, 5, 6, 7, 8. For example, sometimes we might do, let's find the last test, see what they did on the very last test, like end of year exam. We only use that one, and that's not useful for the mean. We might do a median, or we might just measure what happened. We just do a comparison between the last one and the first one. Get me? So where they go from the start to the end, but because we're including 1 to 8, mean is better. Now with that little hint, I want you to look at your notes now. What about spread? Which one of these spreads, range, IQR, and standard deviation, uses all of the data? Standard deviation. You can do range as well, but range doesn't tell you a lot of information compared to standard deviation. Okay, so the proper answer for this one, standard deviation, is like your mean. Remember, I highlighted in blue for you over here. So if you chose mean, you can do range, but I already said it doesn't really tell you much further information. Standard deviation is the next one. Okay, so for year 12, it's all about doing on your Excel. So here we go. Mean for center and standard deviation for spread. And the key information was the fact that you're using every single value. Okay, that's the biggest hint. All right, here we go. So now it says, determine which student had better overall performance. So how do you do that? Well, let's do a mean and standard deviation test. And like I said, the best way to do it is Excel. So I'm going to show you how to do it in Excel. Here we go. I'm going to open up Excel. There we go. Let's do column A. Let's call him John, and column B, Penny. I'm going to zoom in so you guys can see. Let's see. John got 45.62. So 45 for the first test, 62 for the second, 64. 55, what are the next numbers? 58, 51, and 59, 62. Okay, so you see how I'm just entering all the data in? Let's go with Penny. What numbers for Penny? We've got 84, 37, 45, 80, 74, 44, 46, and 50. That's probably the hardest bit that you have to do. So I've entered all my data. Now to find the average, this is how easy it is. On your Excel, there's a formula for it, and this is all you type. To find the average, you type in AVG, open brackets. So type in equals AVG, open brackets, and you highlight the cell. So here we go. I'm going to do an example for you to see. Equals AV, actually it says average there. Sorry, average. You actually write out the average. Open brackets. And you highlight the cells, just like that. So you literally type in the word average, open brackets, close the brackets, and you got an average of 57. It's a lot quicker than doing your calculator where you do 45 plus 62 plus 64 plus 55, and you add all the 8 numbers together and divide it by 8. It's much quicker to do it here. So type in average, open brackets, highlight the cell, and then close brackets. Okay, I'll do it again just so you can see. So click a cell, doesn't matter where. Equals average. I spell out the word average. Open brackets, highlight the cell. So I'm going from B2 all the way to B9. Close brackets. There's my average. So I got 57 and 57.5 for the averages. Let's look at standard deviation now. So this is average. Let's look at standard deviation. Now, standard deviation, for those who were here in the last session where I showed you how to do it on Excel and you weren't paying attention, this is what you type in. You type in equals. Actually, I'm going to type it here so that you guys can see. Standard deviation. This is what you type. You type in equals and you type stdev.s. Open brackets. Why S? Because it's a sample. You're not doing a whole class of students of 25 students. You're only doing 2 students. So you do a sample, so it's .s. Here we go. I'm going to show you this cell equals stdev.s. Open brackets. Highlight the cell for John. There we go. I got 6.4. Much quicker than had you done it by hand. Here's another one. I'll do it again. stdev.s. Just means standard deviation for a sample. Open brackets. Highlight the cell. Close brackets. All right, now we've got our info. Let's have a look at the averages. Who had a better average? John or Penny? Who had a better average? Let's go, Jack. Penny, obviously. Penny has 57.5 as an average. John had 57 as an average. Penny did slightly better in terms of performance. Standard deviation, now this is where I was trying to tell you. Let's remind the U12s again. What's standard deviation? It's how far away from the mean. So what's the average, right? Now if you look at John has 6.4 away from the average. Penny has 18% away from her average. So if you think about that, what does that mean? If you have a score that's further away, standard deviation, that talks about how possible she could get. She could get 57.5 minus 18, so really low, or 57.5 plus 18, or really high. Versus John can get 57 plus 6.4, or 57 minus 6.4. So if you think about that, what is the range compared to the two? This is where students may not understand what standard deviation means. It just means John was more consistent, whereas Penny had more variation. So some days, Penny could do really bad because of that big standard deviation. That's what standard deviation means, because Connor said it was the distance away from your mean, how far away you are from the mean. If you're 18% away from your average, you're huge. It's like saying if you got 60 and I said you could be plus 18 or minus 18, you could be like anywhere close to 80 or anywhere close to 40. Whereas John's getting 57, adding 6 is 63 or 51. He's more consistent. He's staying between the 50s to the 60s. That's much smaller. So he doesn't fluctuate so much. Penny does. So that's what the spread does. The spread tells you how much variation there is. So you can see, yes, whilst Penny had a bit better average score, but her consistency does not look as good. So it means throughout the year, end of year exam, it could really flip. She could do really bad on the exam, whereas John, I can predict that he'll probably be sitting between 50s and 60s. Get me? Okay, so that's what you take out for the year 12. So for year 12, understanding is that explanation. So that's what this question was asking. You would have wrote here, after doing your calculations, you would have got mean for both of them, and you would have got a standard deviation. So John and Penny. John had 57, Penny had 57.5, John had 6.4, and Penny had 18.4. Somewhere there, right? Part C was determined through the interpretation. So here you can say which student was more consistent over the 8 tests. It had to be John. John was more consistent because his standard deviation was so much smaller. And that interpretation was just Why didn't that write out? It's much smaller. And hopefully in this one exercise, in this one example, you're understanding what standard deviation does. It's the measure away from your average. The larger the standard deviation, the more variability there is. Oh, so that exercise goes back to this one. Where is it? It was measure of spread 6.3. There was this sheet that I gave out. It was that ugly formula. So this one you don't really want to do by hand if there's a lot of data. You have to take their data minus their average, square it, and you have to do it for every one of them. So this was the example where I did this table. So I said, how do you find standard deviation of 4, 6, and 8? I had to do 4, take away the mean, and we calculated the mean here. We found out the mean was 6. So 4, take away 6 is -2, and then you have to take 6, take away 6, which is 0, and then you have to do 8, take away 6, which is 2. Square all those numbers, you get 4, 0, 4. Then you find the average of that, or like total of it. Now you get 8, and the very bottom part, because it's a sample, you have to do 8 divided by the number of numbers. So it will be 8 divided by 3, square root. So this was a huge formula, and that's why I'm saying, yes, you can if you want to know how to do it by hand, but at the end of the exam, you don't have to. It's more to understand what standard deviation does. So that's why I taught here, it's probably better to do it Excel. You just type in stdev, and it's .p or .s, depending if it's population or sample. Most things are sample, so the smaller group. So if I just chose Billy and Kellen to do the test later, that's a sample. Population is if I got all of you to do it. Okay? All right, team. That will summarize for today's lesson. That was a good question. How do you find standard deviation by hand? Really, to be honest, don't memorize the formula. You're not going to be needed for both 11 and 12s. You don't need to do it by hand. You do need to know what it means. So if I gave you a standard deviation, something like this, you needed to be able to say, John was more consistent, and explain why. And hopefully now you understand what I mean by away from the mean. Whatever their average is, how far away from that average, that tells you the spread. Okay? That's 6.5. No, I don't expect all of you to be up to 6.5. I do expect that you will have some time to complete, up to 6.5 eventually, but it's not until week 7. So next week, that's when I start checking through your homework. And I expect everything on this page here on the front one, that you know how to find the mean, median, mode, range, interquartile range. Standard deviation I only expect through Excel. Okay? So if you just know how to do what I just did on the Excel, that's good enough. Cool? All right, year 11s, you have a choice. You can either do the 6.5 from the year 12 textbook, or you can have that time to go back and make sure you catch up to 6.4. Okay? Whereas year 12s, you now have time to either catch up doing the stuff that you had missed, going up to 6.5, and I'm going to be returning the quizzes whilst Billy, Callan, and someone else who still hasn't done the quiz. Who is that again? Let me see.